evening, everyone. Am I audible?
Yes, sir.
Yes, sir.
Okay. Shall we get started? Kaushik, are you there?
Good evening, sir.
Yeah, good evening. So we'll get started and solve the problem. Okay. Yes. So tell me how to solve this one. Find the ratio of the intensity at the center of bright fringe to the intensity at point 1/4 of the distance between the two fringes from the center. So how to solve this? Find the ratio of the intensity at the center of the bright fringe. Right. See, if I take intensity of source to be I naught, okay. So what I'm saying is, if I take the intensity of both the sources to be I naught, then I know that the resultant intensity is 2 I naught into 1 plus cos phi. Okay. So resultant intensity will be equal to 2 I naught into 1 plus cos phi or 4 I naught into cos square phi by 2. Okay. Now my question is very simple. See, for the bright fringe to be formed, what should be the phase difference between both the waves? So for bright fringe to be formed, the phase difference between both the waves should be 0. So if I take the 0 value and substitute it here, intensity of the bright fringe is going to be equal to 4 I naught into cos square 0 by 2. That is 4 I naught only. Correct, Ada? Am I right?
Yes, sir.
Okay. Now, read the question carefully. They are asking what is the intensity at the bright spot and 1/4 of the distance between two fringes from the center. So 1/4 of the distance means it is somewhere between two bright spots. Am I right? So that is going to be a dark spot. For a dark spot, tell me what is going to be the value of phi.
Phi by 2, sir.
Think and tell me now. Phi by 2, correct? Akash,
Sir.
phi by 2, correct? Correct, then. be confident. Only when you have this, right, you're going to have a dark fringe that is formed. So when you substitute this value here, then what is going to be the value of I resultant? It will be 4 I naught into cos square. In the place of 5, put pi by 2, and you have a by 2 here. So it is 4 I naught into cos square of pi by 4. That will be 4 I naught into cos square pi by 4 is 1 by 2. So this will cancel this twice. So it will be 2 times I naught. So I bright divided by I at d by 4 will be equal to 4 I naught divided by 2 I naught, which will be 2.
Sir,
Ah,
sir, so here the distance doesn't matter, right? Like it's only the phase pi by 2 matters. It can be
see, listen.
butter.
1 minute. I want to explain this concept. இப்போ இந்த wave இருக்கு. See, those who don't know this concept, listen to this. Nitish, you answer the questions I'm going to ask you. How much is this distance?
Lambda.
So, for one wavelength, what is the corresponding path difference?
2 pi.
Right? For a path difference of, let's say, P, what is going to be the equivalent phase difference? Can I take it as 5?
Yes,
Right?
sir.
So, which implies P will be equal to 5 divided by 2 pi into lambda.
Yes, sir.
Okay. இப்போ எனக்கு சொல்லு, according to the concept of fringe width, what will be the path difference between two successive bright spots or two successive dark spots? So between two successive bright fringes, what is going to be the path difference?
Lambda d by d.
அது வந்து fringe width. நான் கேட்கறது path difference. நீ சொல்றது வந்து fringe width that comes in the Young's double slit experiment. It will be lambda by 2.
Yes, sir.
I'm talking about the path difference. Okay. So what did they say? 1/4 of this. Right? 1/4 of this எவ்வளவு இருக்கும்? So lambda by 2 corresponds, see, lambda by 2 is the path difference. What is going to be the corresponding phase difference that is going to take place here? That will be pi.
Yes, sir.
அப்ப lambda by 4 ஆனா
Pi by 2.
that is what I do. Okay, here it matters, but in this question you got this pi by 2 because of this reason. Okay, புரியுதாடா? இல்ல confusion இருக்கு?
Got it, sir.
So for Young's double slit experiment, if you see, the condition for path difference, right? is going to be n times lambda for you to have a bright fringe. For dark fringe, the path difference is supposed to be 2n minus 1 into lambda divided by 2. Okay. Similarly, the distance of the nth bright fringe from the center of the screen is going to be n into lambda into capital D divided by D. Okay. Make a note of all these formulas. Similarly, distance of the nth dark fringe from the center of the screen is going to be 2n minus 1 into lambda into capital D divided by 2D. Okay. Then fringe width is given as lambda into capital D by D. And see, generally this experiment is done to calculate the value of lambda also. It will be beta into small d divided by capital D. Okay. Similarly, there is something called as angular position of the nth bright fringe, which is given as n into lambda divided by small d. So angular position of the nth dark fringe is given as 2n minus 1 into lambda divided by 2d. Right. So having all these values, let's try to solve some problems. In Young's double slit experiment, the two parallel slits are made 1 millimeter apart. And a screen is placed 1 meter away. What is the fringe separation when blue-green light of wavelength 500 nanometer is used? So this will be equal to 500 into 10 power minus 9 meter. So tell me what is going to be the value here. What is the fringe separation? So beta is equal to lambda into, so what is the formula? Lambda into capital D divided by small d. So lambda is 500 into 10 power minus 9 into capital D is 1 divided by 1 into 10 power minus 3, which will be 500 into 10 power minus 6 meter, or this can also be written as 0.5 millimeter.
Sir,
Tell me.
no, sir. Shall I proceed? So laser light of wavelength 630 nanometer, that is 630 into 10 power minus 9 meter, incident on a pair of slits produces an interference pattern in which the bright fringes are separated by 8.1 millimeter. So beta 1 is equal to 8.1 millimeter. A second light produces an interference pattern in which the fringes are separated by a distance of 7.2 millimeter. Lambda 2 is equal to what? So beta 1 is equal to lambda 1 into capital D divided by small d. Beta 2 is equal to lambda 2 into capital D divided by small d. So beta 2 divided by beta 1 is actually equal to lambda 2 divided by lambda 1. So what is the value of beta 2? 7.2 divided by beta 1 is 8.1 is equal to lambda 2 divided by lambda 1 is 630 into 10 power minus 9. So this goes
8 by 9, sir.
So it is going to be 70. So lambda 2 is equal to 560 into 10 power minus 9 meter.
or this is going to be 560 nanometer. Got it? Try this.
Sir, 1 millimeter.
0.5. So lambda 1 வந்து 6000 angstrom. Beta 1 is 0.8 millimeter. So lambda 2 is 7500 angstrom. Beta 2 is equal to how much? If the distance between the slits is doubled, so D1 is D and D2 will be 2 times D. Did you use this?
No, sir.
So beta 1 is equal to lambda into D divided by D1, and beta 2 is equal to lambda 2 into D divided by D2. So beta 2 divided by beta 1 is equal to lambda 2 by lambda 1 into D1 by D2. So lambda 2 is 7500 divided by lambda 1 is 6000 into D1 is D and here it is 2D. So this goes 5 times, this goes 4 times. So beta 2 is equal to 5 by 4 into half into beta 1. So beta 1 is 0.8. It's 0.1. So 5 into 0.1 is going to give you 0.5.
Sir, could you show the question possible?
Yeah.
Understood.
Yeah. Okay. So this is another concept where there will be some, see, this is very rarely asked in CBSE, okay, but I have seen questions here and there. So it's better we know this concept also. Intensity ratio at maxima and minima of an interference pattern. So one thing you need to make a notice, intensity of light is directly proportional to the width of the slit. See, that is logically right, because more amount of light is going through the hole, then more intense image is going to be formed on the screen. So that is the first point. Second is ratio of slit widths. So W1 by W2 is going to be the width of the slit. So W1 by W2 is equal to I1 by I2, where I1 and I2 stands for the intensities, is equal to A1 square by A2 square, because intensity is directly proportional to amplitude square. Okay. Next, if you know this value, then intensity at maxima is directly proportional to A1 plus A2 the whole square. Similarly, intensity at minima is directly proportional to A1 minus A2 the whole square. Then the intensity ratio at maxima and minima is given as I max by I min is equal to A1 plus A2 the whole square by A1 minus A2 the whole square. Okay. What is the ratio of the slit widths with the amplitudes of the light? Amplitude of light leaving from them have a ratio of √2:1.
So 2:1.
So, அவ்வளவுதான். So I1 by I2 is equal to A1 square by A2 square. So √2 by 1 the whole square, that will be 2 by 1. Two coherent sources have intensities in the ratio 25:16. Find the ratio of the intensities of the maxima to minima after interference of light occurs. So I1 by I2 is equal to 25 divided by 16. Find the ratio of the intensities of the maxima to the minimum. So how to find it, guys?
A1 by A2 is 5/4.
Okay. A1 by A2 is equal to 5/4. So I max is equal to, or I max by I min, can I write it as A1 plus A2 the whole square by A1 minus A2 the whole square? Then what I can do is I will take A2 outside, then I'll get A2 square into A1 by A2 plus 1 divided by A2 square into A1 by A2 minus 1. Here square, these two will get cancelled. So A1 by A2 is 5/4. So 5/4 plus 1 is going to be 9/4 the whole square divided by 5/4 minus 1 is going to be 1/4 the whole square. So 4 and 4 will get cancelled. 81:1 is the answer.
Sir,
Tell me.
sir, I have a doubt.
Yes.
Sir, can you hear me?
Yeah, I'm able to. You tell me. Are you able to hear me? Are others able to hear me? Can someone respond?
Yes, sir.
Yes, sir.
Okay. Subrajit, are you able to hear me?
Yes, sir. Now I am.
Now tell
Sir,
me. Yeah.
in this question, why like if we do A1 plus A2, say we take X as like the multiplication factor, and
Okay.
we do it as like 5x plus 4x upon 5x minus 4x.
Mm-hmm.
So it's 9x the whole square upon x the whole square. So 81
You can
upon
do that.
x.
You can do that. You
Can
can
we?
do.
Okay, sir. Okay, sir.
You can do that. See, what you're doing is basically you're multiplying this and this with x. You're adding them and taking the square, is that right?
Yes,
So
sir.
what you're doing is called as componendo dividendo in terms of ratio and proportion. It's called componendo dividendo. That is a mathematical operation. You can do it. Or you can add one on both the sides, do it. There are multiple ways to solve it. Okay. If the
Okay.
two slits, yeah, if the two slits in Young's double slit experiment have width ratio 4:1, reduce the result ratio of the intensity at maximum to the minimum in the interference pattern. Answer.
Nine.
9 is the answer. Let me check.
9 stone.
Correct. So 9:1. It's the same logic again, right? So thin film, we don't need. So we'll do some problems which are based on diffraction. So somebody asked me about diffraction. Is he there? Kaushik, are you there? So we'll get started with this. See, for diffraction at a single slit of width A, what is the condition for the nth minimum? The condition for nth minimum is A times sine theta should be equal to n lambda. Similarly, the condition for the nth maximum is given as A sine theta is equal to 2n plus 1 into lambda by 2. And what is going to be the angular position or direction of nth minimum? It will be n into lambda divided by A, and the distance of nth minimum from the center of the screen is going to be this one, n into lambda into capital T divided by A. Similarly, angular position of the nth secondary maximum is going to be 2n plus 1 into lambda by 2A, and the distance of the nth secondary maximum from the center of the screen will be 2n plus 1 into lambda into capital T divided by 2A.
Sir. Sir, here A means like small d, right?
A is small d.
Okay.
So if I have to show you the diagram, it is like this. This is A, and theta is the angle through the which the rays get bent, and P is the point where the image is formed. Okay. Similarly, width of the secondary central maximum is always twice the width of any other maximum. So B naught is always equal to 2 times beta, which is given as 2 into lambda into capital T divided by A. Right. Similarly, the angular spread of central maximum on either side is going to be plus or minus lambda divided by A. Plus or minus lambda divided by A. Okay. So the meaning of it is this angular split will be lambda by A, and here also the angular split will be lambda by A. Okay. what is going to be the total angular split? Lambda by A plus lambda by A. That is 2 times lambda by A will be the angular split, sorry. So this is not needed. So based on this, let's get started with the problems. Question is, from of a diffraction from a single slit of width 1 micrometer is observed with light of wavelength 500 nanometer. Calculate the half angular width of the central maximum. So what are the values given? A is 10 power minus 6 meter. Wavelength is 500 into 10 power minus 9 meter. Calculate half angular width. Okay. So what is angular width of central maximum? It is 2 lambda into capital T divided by A. Half angular width will be or can I say it like this?
Sir,
Half angular width will be the width of any other central maximum. So can I say A times sine theta is equal to lambda, which implies sine theta will be equal to lambda divided by A. So 500 into 10 power minus 9 divided by 10 power minus 6. So how much will be the answer? It will go 10 power minus 3 times. So sine theta will be equal to 0.5. Then what is the value of theta? Theta will be 30 degrees. So this is going to be the half angular displacement. Why do I call it as half angular displacement? Because it is the width of any other central maximum.
Sir, could you show the question? Understood, sir.
So light of wavelength 600 nanometers falls normally on a slit of width 1.2 micrometer. So wavelength is 600 into 10 power minus 9 meter, falls on a slit of width 1.2 into 10 power minus 6 meter. Calculate the angular position of the first minimum and the angular width of the central maximum. So what is the angular position of the first minimum? So condition for first minimum is A sine theta should be equal to lambda. So A is 1.2 into 10 power minus 6 into sine theta is lambda, that is 600 into 10 power minus 9. I think you will get the same thing. So sine theta will be equal to 0.5, which implies theta will be
30 degrees. Then what is going to be the angular width of the central maximum? Angular width of central maximum is going to be 2 into 30 degrees, which would be 60 degrees. Okay. Do this. Microwaves of frequency 24,000 megahertz are incident normally on a rectangular slit of width 5 centimeters. Calculate the angular spread of the central maxima of the diffraction pattern of the slit. So angular split is going to be 2 times lambda divided by A. So angular split will be, angular spread will be 2 times lambda divided by A. So 2 into, what is the value of lambda? How to calculate the value of lambda when the frequency is given?
So C by
So distance is equal to speed into time. Right? So it should be half reading.
Sir,
Tell me.
sir, could you go to the previous question? Sir, so if they ask angular width, we have to calculate sine theta and then put, like,
Yeah.
we have to calculate
It
sine
got drawn
theta.
off a
But if we ask angular spread, we have to calculate. Oh, okay.
drawn offer, then calculate sine theta.
Sir,
Ah,
sir, but in the book we are mostly approximating sin theta as theta, right? Why is it so?
see, that depends on the problem. See, here 30 degrees you can't approximate. Whereas here, what you're doing is angular spread when you're calculating it as 2 lambda by A, because see, if this is there, the light ray is getting bent in such a way, okay, that this position is the first dark spot and this is also first dark spot. So how much is this angle? Lambda by A. And how much is this angle? It is lambda by A. So what will be the total angular spread that is happening? It will be 2 lambda by A. That is why you wrote this one. Okay. So experimentally speaking, these angles are small only.
Okay, sir.
Yeah. So resolving over it all or not there. So that is all with respect to wave optics also. Okay. So yesterday, I think Kaushik from the I think he has not yet joined. Okay.
Is there any other doubt from this chapter? It is not clear. Any concept that is not clear. Provided you have gone through the videos and then you're asking the question.
Sir, for this lesson, there is no derivation, right?
There is no derivation again.
Yes,
Did you ask no or more?
no.
There are no. There are derivations. I'll show you. But this loss of refraction based on wave theory is a derivation. Demonstration of IDSC, conditions for sustained interference circular. That is a
Yes.
derivation. Relation between path difference and phase difference is a derivation. Then interference and conditions for constructive is a derivation. Loss of reflection is a derivation. This full diffraction in the 18th வரைக்கும் it's fully derivation. So it is there. அதே மாதிரி Young's double slit experimentல கூட இது derivation.
Sir, derivation, it's not, it seems like it's not there for CBC.
I don't think that they can ask you. They can ask you. See, I will tell you this. In this chapter, problems are slightly tougher. Without you knowing derivation, I don't think you'll be able to touch it. Did anyone tell you that they'll not ask you for CBC? Or you check previous papers and you're asking me the question?
No, sir.
Did they tell
Yes, sir. In the
They're
school.
school it was informed that they will not ask.
Yes, sir. For this.
See, I would
Till
not recommend.
till Huygens principle, it's there, sir. But the derivation for YDAC.
1 minute, wait. 1 minute. Let me check if they have given only. I'm just checking the syllabus again with the benefit of doubt. For YDSC, I'll show you that. For YDSC alone, they have included this.
Sir, can you come again?
I've opened the syllabus. Proof of loss of reflection and refraction using Huygens principle. Interference. Young's double slit experiment and expression for fringe width. No derivation. They have told no derivation and final thing. Okay, diffraction due to a single slit width of central maximum. I don't know what their qualitative treatment is. I will tell you one thing. See, don't go very strict with respect to the syllabus that they have given. I'll be very honest. CBSE itself doesn't follow. Like last year and all, matrices and determinants, actually the problem based on properties were deleted. Okay, but you were asked in the exam. So though they will give you marks, that's a different story. But in the exam hall, you will be unnecessarily in a pressure that you don't know that. So you have already learned it. No? I would suggest better practice and do.
Okay.
They can do at any point of time. Unnecessarily, instead of we being in a tension whether marks will be awarded or not, it's better, safe side. So yeah, that is what I suggest every time. Have some extra information. There is nothing wrong.
Okay.
Yeah.
Yeah.
Where? So that is all from this chapter, right? Okay. See, if that is the case, we'll wind up. Okay. Dual nature and atoms and nuclei, I'll have it on Friday. Friday, tomorrow evening, right? Tomorrow evening is when I told you compensate. So we'll have a discussion on dual nature and atoms tomorrow. Okay, all are small chapters. Okay. So I suggest you to go through the theory before coming to the class. Okay. So shall we wind up? There are no more doubts. Okay. Yeah. See you.
Thank
Thank
you.
you, sir.
Thank you.